Yeah, good afternoon. We are Zihao Rao, Jerry Tan, Hui Wang from Alibaba Cloud, DaoCloud, and VictoriaMetrics. We are pleased to introduce the talk on behalf of OTel community. With the support of OTel community, TC, and the GC members. Last, we will expand our talk from following two parts. Part one, OTel community update in 2025. Part two, introduction of OTel Viv. Before the introduction, let me do a small service introduction of myself. My name is Zihao Rao from Alibaba Cloud. I'm also an approver of OTel Java instrumentation. I will introduce something about part one, and the remaining are given to my co-speakers. OpenTelemetry is an observability framework and toolkit designed to create and manage telemetry data, such as trace, metrics, log, and profiles. The major goal of OTel is you can easily instrument your application or system, no matter their language, infrastructure, or runtime environment. Just like the picture shown here, we provide all kinds of different language instrumentation and SDK to achieve this goal. Last but not least, OTel is a vendor and tool agnostic, meaning it can be used with broad variety of observability backend, including open source tools like Prometheus or Jaeger, and some as well as some commercial offerings. Before starting this talk, let me do a small survey. How many people here have not only heard about OpenTelemetry but understand semantic convention in it? Please raise your hand. Okay, cool. I want to highlight point that semantic convention is the soul of OpenTelemetry in my mind. It's like a reference menu for implementation, all kind of different language SDK or instrumentation. It provides and tells the SDK or instrumentation which data we should collect in different language, and how to define the data model in different language SDK or instrumentation. Just like in the picture, this is a simple client-server example. And in this picture, you can see no matter in client or server, server address or server port are necessary. We should collect it. They are defined in semantic convention. And on the right, you can see this is example of HTTP server span. And we can see this line, there are some attributes. And this line, there are some requirement level. And in semantic convention, it will take related developers or users, which one is required and which one is optional. And this is like a reference menu. OTel semantic convention involve line 6, 74 domains, and 900 plus attributes. Maintainer of this project spent a long time on definition and specialization of all kinds of fields in OTel, such as there are some field like database client or code attributes or system metrics. They are on closing in stabilization, and there are some other field like RBC messaging and feature flag or Kubernetes metrics. They are upcoming stabilization. If someone interested in related field, you can join us. And other highlight like CI/CD or JNI or brochure and mobile. There are some highlight field, especially over the last year. There are a lot of contributor or developer involved in related field. I also want to say thank you to them. Next one is OTel profiling. Over the last 1 or 2 years, there are a lot of things happened in OTel profiling. Before introduction of update in related field, let me do a small introduction of its concept. Just like in this picture, OTel profiling is a technique to dynamically inspect the behavior and the performance of application code at runtime. You can see here, there are some metrics of CPU memory. If we see these spikes in metrics, we don't know what happened behind these metrics. With profiling, we can collecting related stack trace dynamically and help us to analyze what happened behind these metrics and which code codes these questions. And especially if someone use instrumentation frequently, this picture you are familiar, I guess. You can see this is a monetary blind spot. If I am a user, I want to know what happened in this port and why the latency here is so long. And I don't know which trace or which band contribute to it. And with profiling, it can help us to collect related stack trace and help us to handle this question easily. This is the concept of profiling. Let's see what the milestone of OTel profiling. Starting from discussion comments in 2022, the field has accelerated significantly over the past 2 years. You can see some main milestone. And I want to highlight is, last year, we land OTEP support in collector and merge OTel collector receiver for eBPF profile. And after OTel profiling, and let's take a look what happened in all kind of different language instrumentation or SDK. In terms of Java, the exciting things is OTel Spring Boot Starter. At the end of last year, Java SIG released OTel Spring Starter a stable version, and we can see this provides user implement to Java agent and SDK. It can provide a familiar access for Spring user, and they just need to add a dependency and do some simple configuration, and they can generate observability data for their Spring application. And there are some common scenarios for user to use OTel Spring Boot Starter. And besides a lower startup overhead and native support for Spring configuration, and the very interesting is that it supports for a Spring native image application. It means we can generate OTel observability data for GraalVM application. And you can look on the right. There are some components of this version support. And the next interesting thing is declarative configuration in Java. And at the end of last year, OTel Java instrumentation support declarative configuration. It contains 3 ports, just like this slide show. And I want to highlight that is, with the declarative configuration, we can define all configuration in a file to control our application or SDK. Just like this figure show here, we can define log provider, meter provider, or trace provider, and all kind of configuration for our OTel Java agent. And besides Java, let's look what happened in Golang instrumentation. In 2024, OTel has received no one but 2 donation proposals from industry leaders to provide a solution to the problem in current Go instrumentation and enable the use of zero-code, vendor-neutral, and compile-time instrumentation in Golang language. And this year, community initiated a related seek co-founded by Alibaba, Datadog, and Cosma to promote a better Go language observability experience for users. And there are some feature of this solution, and you can see this is the process. The initial idea is that we inject observability logic to our Go application in compiling time, and this is a benefit of this solution. And we also have a related talk this afternoon to introduce this plan in detail. And if someone have a question, and we can discuss them later. And last but not least, in JNI and over the last year, OTel hosted Python instrumentation, support OpenAI, Vertex AI, AWS Bedrock runtime, and Google GenAI. And there are some work, maybe they are in process. And if someone have interesting in related field, you can post your question in related Slack and in related GitHub channel. And there are something I want to introduce. Next, welcome to my co-speaker, Jerry Tan, to introduce something from OTel Collector. Thank you.
Wait. Thanks, Zihao. My name is Jerry Tan. I work at DaoCloud, and I'm a approver of OpenTelemetry Helm-Chart project, and I'm also a treasurer of OpenTelemetry Collector contribute project. Next, I will share you something with the latest of updates of OpenTelemetry Collector. But before that, let's start with an introduction to OpenTelemetry Collector. Collector is an important component of telemetry. It offers a vendor-agnostic implementation of how to receive and process and export telemetry data. Here is an architecture of a diagram of how to for OTel Collector that explains us exactly how everything works. As we know, OpenTelemetry provides instrumentations, SDKs for instrumenting various programming language and frameworks. This libraries provides traces, metrics, and logs in a vendor natural standard format that can be forwarded to the collector. Telemetry data is received by different receivers and then processed by processors, and finally will be distinguished to distributed to any place and any destination you want to, like Jaeger, vendor, or standard basis. This is a sample of our blog since the beginning of this year. With the graduation of OpenTelemetry, auditing is an inevitable topic for a major project. Collector completes the phasing audit marks a significant step for OpenTelemetry. It's ensuring the security and reliability of Collector for its users. OpenTelemetry Collector extension Lambda supported by Amazon. It allows you to run any processes alongside your code, sharing the execution runtime, and providing additional services. But not all updates will be introduced in detail here. Next, I will focus on introducing the Kubernetes annotation-based discovery and the OTTL model updates. As we know, when we need to re-observe the observable objects, we need to update the configuration of OTTL collector, and we need to restart it and make it to work with the new configuration. But now, dynamic discovery of observed objects can be achieved by the Kubernetes observer and receiver creator, which greatly reduces the complexity of OpenTelemetry collectors deployment and operation and maintenance in the Kubernetes environment. Simply speaking, when the Kube observer handler monitors the Kubernetes API through and detected some changes in port with specific annotation, it notifies the receiver creator through list and watch function and passes the annotation configuration. According to the configuration, the corresponding receiver is dynamically created. The unit created begins to collect the telemetry data from the target endpoint. So we only need to create the discovery rules of receiver creator and configure the permission and features of the Kube observer to enable this feature. More details we can check the link at the bottom here. Another update is the OTTL module. OTTL, but we have to review first what OTTL is. OTTL is a powerful domain special language designed for interacting with telemetry data in collector. It is widely used in various processes and filters, and it is a core technology for achieving the flexible data transformation. Typically, an OTTL statement contains functions, fields, context, and some logic operators. Here is an example given. We determine whether the body contains an error value in the log data on the right. If matched, we set the severity number to the severity number field to the severity number error value enumeration. The supported context inference makes it more convenient for us to write statements. We don't need to. The context inference is based on the path names, functions, and the enumerations present in the statements. With the context inference, we don't need to strictly isolate and distinguish statements from the context for maintenance. Users who have deeply used OTTL may be deeply impressed by the pain of writing and debugging the OTTL statement. And now the OTTL playground developed the tool. The OTTL playground developed by Elastic can enhance convenience. OTTL playground is a powerful and user-friendly web-based application designed to allow you to experiment with OTTL statement in the web UI. It's built with WebAssembly, which means the code runs under a host is the same as the live collector. Here's a demo. Let's start it. We can find on the left is where we fill in our OTTL statements. Sample data of traces and logs are also provided on the left and at the bottom. On the right, when we can see when we run the green button run, the right is a different result will soon presented to us. Where is the OTTL statement and the sample data take effect. Besides, we can also copy. We can share it with other friends by copying the link, which improves a lot of comparison. So next, let's leave the time to my partner Hui Wang.
Hello everyone, my name is Wang Hui. I am a software engineer in VictoriaMetrics, and today I'm going to introduce you to Weaver. So, according to previous survey, few of you know semantic convention. That is kind of break by plan. So anyway, in my opinion, semantic convention is like a place which you can define all your telemetry data in there, and you can look up for things for everything, like a dictionary. So anyway, OTL provides official semantic convention repository, and in there you can find a lot of documents, and you can use its SDK in your application. And you may find them very helpful. And have you ever wondering how everything is maintained inside the like how the documents are generated, how the check was running, like to ensure everything is okay, not to break things for everybody. So if you want that, and you may wonder, can I have the similar thing for my telemetry convention, things like that? Of course, you can have it. The OTL community provides a tool called Weaver, and here is a simplified diagram of how Weaver works. So basically, it requires a convention registry as an input. And again, this registry can be the official one or your own registry. And it has things like resolution process allow you to reference things. It has policy engine, template engine, so you can customize all your artifacts and checks or things. Okay, let's just break this down. So first, document. We all like document because it's easy to read, to understand, and well-structured documents can like facilitate the use of telemetry data for machine learning. Like in this example, I have a metric definition here. So I have its type, its name, and with the generate command with the markdown template, I can get a markdown and I can publish it or for user to read. Okay, besides document, Weaver can also generate SDKs. Like here, I have a server request counter. Like here, it's about the same definition as the last one. And if I run generate command with the Go template, it will generate this pile of code here. And you can see there is a new method, which is it initializes this metric. And since it's a counter, which value can only go up, there will also be an add method. Then I can implement my application. And when I do that, I can just call those two methods without redefining my metrics. They're pretty cool. The second thing, check. So when I write this convention, I may make mistakes like typos to refer things that do not exist or make other mistakes. In that case, I can use the check command to ensure everything is good, everything has good reference, and you can also use a policy language called Rego and provide to the Weaver, and it will check all things. So the check command is kind of a static check to check if your definition is good. But what about things like runtime validation? Like if you already finished your application and you want to ensure the application generates the correct telemetry data, then you can run Weaver with live check command. It will start an OTL listener, and you can configure your application or OTL collector to send data to Weaver. Then Weaver will compare the live data against the registry to tell you if the received data contains illegal things that is not defined in the registry. And it also provides you a registry coverage percentage, so you will know how much of your schema has been implemented. It can be like integrated into your CI/CD pipeline to get continuous validation. And yeah, so the live check allows Weaver to receive data. What about doing things reversely? Like can Weaver generate data? Yeah, of course. So here, when you define those attributes, you can also specify some example values, and then you run Weaver with this emit command. Then Weaver will start to generate data based on your schema, based on these example values, and you can send it to this endpoint. For example, for metrics, you can let Weaver to generate data and send it to a time series database. Then you can kind of see how your dashboard will look like even before your application is finished. Okay, last thing, diff log. So over time, you will like involve your convention, like you want to introduce some new things, you want to deprecate some old things. Then in that case, the changes can be introduced for good reason or by mistake. But either way, you want to have a diff log to ensure nothing is overlooked and everything is recorded for user to migrate, things like that. So you can run this diff command with the current registry and the previous registry. It will generate you a diff log. Like in this example, I introduced, I kind of replaced some old attributes and marked some attributes as like deprecated. And this is pretty cool because the diff log can be translated into changelog directly, or the diff log can be consumed by other products. Like now there is a collaborative proposal between Weaver and the Prometheus community to make Prometheus understand this diff log. That means if you renamed your metric, changed some label or unit, you can generate this diff log, which should contain every change, and Prometheus should be able to read and understand this changelog. Then during query time, you can just, the query engine should be able to migrate all the data across versions. So your dashboard your existing dashboard or alerting rules won't be break because Prometheus know what it look like. Okay, I will do a quick live demo if I have time to show like how those commands can be used. I will do it pretty quick. So okay, I will just show you a simple definition here. So I hope so there is a metric. I'm still going with metric. Like it has 4 attributes. It's a counter, it has type, things like that, and I have 2 attributes, which is reference from this registry YAML. So so I have these 2 YAML together. Then so I finished with this metric. The first thing I want to do is to run a check for it. Like I will. Sorry, I can't see the screen. Okay, I will run this check, and it says like I have 2 errors. The first one is like the metric name and ID must follow some certain pattern, like it must do not add things, and I have addition S here. Let's remove that. And the second thing is the size, request size attribute should be like should be not the right one, sorry. Here is the right one. Sorry. So I marked these attributes as development stage. So in that case, I can't use required because it's still under development. I must change it to like opt-in and what it is. Okay, then I run this check again and nothing happened. Okay, then I got the right one. Then I can start to generate things. Let me delete this. Let's not delete it. Okay, I will just run the generate code. And first I run the Markdown, then I run the Go template. And it will generate me 2 files. One is the Markdown, one is the Go SDK. And when I implement my server, like since it's my server, it's for my server, so I can just use it in my server code, like to call the new metric and add to call the new method and add method. Okay, last thing I would show you diff demo, but let's. Okay, sorry. So in addition to above commands, we will also have some interesting future directions. One of them is the diff enhancement. I just mentioned there are also others like support multiple registry, like provide default templates and policies, like all for the users for easily use them. And if you want to see more use case or documents, just check the repository on GitHub. Yeah. Okay. This is all the links we used, and you can check them if, yeah. That's all.